All right. So in this session today, I'm going to tell you how multipod setup is configured and how exactly it works. All right. So this is a generic topology that you would see in case of when you're trying to deploy a multi-pod environment in your ACI fabric. And these two different pods, they can be in geographically different locations. And when I say multi-pod, it can have not just these two pods as we are considering in this example in our session today, but it can include multiple pods. Okay, so these are the spines and the leaves of a generic ACI deployment. These devices here, which I have taken as example, the Nexus 7K devices, but these actually can be any L3 device, any ASR, XRV device, or any router or anything like that, or it can be a non-Cisco device as well. Okay, so these are basically the IPN devices, the inter-pod networking devices, which are not managed by the API controllers. You have to configure, or you have to do the configuration on these devices separately over the CLI or whatever portal they have. The other important point about multi-port setup is on this IPN network, only OSPF regular area is supported and not NSSA or other types of areas. Furthermore, only OSPF is supported in IPN, and in OSPF we have only regular area supported, which is under the infra tenant. Okay. Now the other point is this IPN network only supports VLAN 4 and VLAN 5. VLAN 4 and VLAN 5 are the only VLANs which are reserved for this IPN configuration. So obviously the interfaces which we are seeing in black lines, which are connecting from spines to the IPN devices, they are configured on sub interfaces to support any one of these VLANs that we want to use. The other important point is the MTU has to be 9150, because we are extending the ACI pods in two different fabrics. So they will actually be carrying the VXLAN traffic as well. And as we all know, when there is a VXLAN packet, because its header is longer than the usual one, so we need to have a jumbo frame configuration present, because we cannot afford to have IP fragmentation been done on the VXLAN packets. Now, there's one more point that you should consider if you are trying to make any changes to a spine switch. Just make sure that there is at least one operationally up external link that is participating in the multiport topology. If that is not taken care of, it could bring down the multiport connectivity. Okay. All right. So let's set up the multiport now. So as you can see here, this is the master stroke of all, these are the basic requirements that we need to configure on the IPN devices to make sure the multi-port connectivity is established completely. So the first point is we need to have OSPF configured between the IPN devices and the spines. Okay. The other point is we have to configure a PIM bidirectional multicast for all the unicast, multicast, and all types of traffics to be communicated or traveled between the pods. So for that we need to configure a PIM bidirectional RP address on these IPN devices. The other important point is we have to configure DHCP relay. Okay, so this particular DHCP function of the IPN devices would be actually be used when let's say for example you have configured this side of pod, and using these IPN devices, the TAP IP addresses for pod 2 devices will be assigned from the IPN devices. You'll understand this about this in detail as we go further, how the configuration is done and how it actually works. The other point is we have to configure the MTU of 9150 as have been already explained. Another most important point is, and which is a mandate, that we have to configure, we have to use 40 gig ports or 40 gig lines between the IPN devices and the spines. So this complete IPN network, it's configured under tenant infra slash overlay one. Overlay one is the VRF. Basically, overlay one is the VRF which we are trying to, overlay one is the VRF which actually runs inside the ACI fabric. So overlay one from one fabric is being extended to the overlay one of another fabric using this tenant infra. So we'll check and we'll see how these things are done. The OSPF neighborship is done between the IPN devices and the spines. I have given here the IP settings that I'll be showing you for reference. VLAN 4 will be used for reference here. We can use VLAN 4 or VLAN 5 as we have checked it earlier. So okay, so as we go further, these IPN requirements, all these configurations will get highlighted as we are going to configure them step by step. And now, because this is a Nexus device, we all know that we need to enable specific features if we are trying to use that particular feature in the Nexus devices. So to support the configuration, this all configuration on the IPN devices, we need to have OSPF enabled, interface VLAN enabled, DHCP should be enabled, and LLDP to let the we all know what the function of these features are. Now, the first step we are going to do is to configure the M2 of 9125. Okay, so here I'm using 1/49.4 subinterface with an IP address of this from the IPN side, and on the spine side I'm using interface 1/20 with this IP address over the VLAN 4. Similarly on the other side as well. For this session, I will only be considering connection between one spine, one interface to one interface of the IPN device. Same procedure can be carried out with all the interfaces as well. So this is the standard way to configure a jumbo frame on Nexus platform. We define a policy map. The class type is defined as network QoS, and under that QoS we can define the M2 as 9150, and then implement that policy on the system using this service policy map type commands. This we can do on both the devices, okay, the IPN 1 side and the IPN 2 side. So M2 914050 has been implemented, which ACI does not support IP fragmentation. That is the reason why we are configuring an jumbo frame configuration throughout the environment. These links are already 40 gig ports between the spines and the IPN devices. So now let's configure multicast on the IPN devices. Okay. So as we all know, during our initial fabric initialization, as I have already told you guys in one of my very initial video sessions, this GPO group address is basically the multicast group address, which is which is a multicast group address pool which is given to the bridge domain when a bridge domain is configured. So how basically it works inside ACI is whatever bridge domain that we are configuring in ACI, it basically acts as a multicast group for the group of EPGs which are bound to that particular bridge domain. Okay, so now because we are extending the fabric from pod 1 to pod 2, we need to have this multicast group. We need to have this multicast group to be extended, and it should be able to communicate to the other pod over the IPN network. Alright, so this is how it should work. And to achieve this, we have to make the IPN network multicast supportive. And that is why for this particular multicast group, we'll be configuring the rendezvous point or bidirectional PIN at the IPN devices. Let's see how. So for this bridge domain multicast group address, you're configuring the rendezvous point on the IPN devices for this multicast group. Okay, so this is the this is a very basic type of configuration that you can do. You can configure same loopback interface on both the IPN devices, give them the same IP addresses. If you do not know what's the logic behind that, I advise you to go through the Cisco guides on configuring phantom RP or bidirectional PIM in Nexus devices. So it's a very pretty simple documents which are available over Google. You can check them out. What is the concept behind using this same IP address and same loopback address? Okay, so uh, these are the RP addresses given for the first one is the bridge domain multicast group, and the other one is to support the bump traffic from one port to another. So this setting has now highlighted. We have configured bidirectional PIM. Going further, now let's configure the IPN interfaces which are connecting to the spine devices. Okay, let's see how the configuration of the interfaces of these sub interfaces on the Nexus side, or rather I should say the IPN devices. What would be the configuration on them? So it's a pretty simple configuration. Whatever MTU that we enable globally on the device, now we are configuring that MTU on the interface level. The encapsulation as mentioned to be using VLAN 4. We have defined its membership with the VRF10 infra, which we are using to extend the port 1 to port 2, right? OSPF, it's a network point to point. That is the only type of OSPF network which is supported right now. We are ignoring the MTU in the OSPF neighborship. It's given in router OSPF area 1 with area ID this. It has PIM sparse mode capability. It has the multicast supportive capability. This particular interface. Then this interface is going to behave as a DHCP relay as well. We'll see how this DHCP relay is configured on these devices and how actually it works. What is the purpose of DHCP relay? We'll check it out. And obviously we don't have to forget about not shut bringing the port up by doing the no shut. Then this is a global OSPF command. We have the router OSPF A1 as a fair OSPF instance. The router ID is given as 93.93.93.2. Okay, so these are the basic OSPF commands. VRF has been defined to use this OSPF instance. So now this OSPF between IPN devices and spines have also been configured. Similarly, on the IPN2 device, we can do a similar configuration. Okay, so now all these parts have been done. Now configuring DHCP relay on the IPN and its interfaces. So first thing we have to implement, we have to activate the service DHCP, and we are enabling the IP DHCP relay on this. And in this command, the IP DHCP relay address is this one. This is basically the DHCP relay IP address for this particular interface, and it will actually be a part of the DHCP relay pool that we will be defining on pod 1 through GUI. I'll show you. And using this IP address, it will actually, these IPN devices would actually be providing the tap IPs to the spines and the leaves in pod 2. Okay, that's the purpose of DHCP relay. Alright, after configuring the IPN devices, now we will configure the multiport configuration settings on the ACI part. So now just to give it an headline, what actually we would be doing is the IPN devices that we have configured already, they would actually be acting as the layer 3 external routers for the infrastructural domain of ACI, right? So what we're basically doing is we are extending the ACI infrastructure from one pod to port 2 over IPN network, which is basically consisting of layer 3 networking. Okay, so when we check under this the fabric policies inventory, pod 1 pod fabric setup policy, we can see here there is already an existing tab pool which is which we actually defined during the initial fabric discovery in the Epic console. So this is the pod 1 and it is the tab pool. This tab pool, all these IP addresses to the spines and leaf interfaces for infrastructural communication inside ACI is given from this tab pool. Now here we will configure the pod 2 and whatever tab pool that we'll be using for that pod 2, and we have to make sure the tab pool is not overlapping with the existing tab pool of pod 1. Now setup pod, we configure a pod 2. I'll just give a random tab pool of, let's say, 1.0.0/16. So whatever spine or leaves or AP controllers would be getting discovered in pod 2, they would actually be taking IPs from this particular pool. Okay, now going further, we have now to create the multipod setup now. So create multipod. All right, the extended community setting, we have to give this in the format of this, which is actually basically the community setting that is used to extend the two sides over BGP VPN 4. So we'll just write it down. This is the standard format, which this is what we have to use. Extended AS2 and then 4. I'll say 9:10, just random number. Okay, we'll keep everything to default. I'll keep it a full mesh rather than route reflector. I'm not going to configure route reflectors on the IPN devices. So the route reflector would be configured on the spines on both the pods and not the IPN devices. Now we have to give a pod a connection profile. Okay, so this would actually be we have to give this connection profile, basically the data plane TAP addresses for both the pods. For one, we can give it as let's say whatever this IP address would be the one which they would actually be using for the data plane traffic between the two pods. Now after giving that, we have to configure the fabric external routing profile. This profile is actually what it's doing is this. Okay, let me mention it: external routing profile. The subnets that we mention here, these subnets are will be the network IDs or subnet masks which actually would be importing from outside to the ACI fabric. And these IP addresses, as per our example, would be the 202.0.0.0 slash whatever subnet mask that I'm going to give here, and 202 and 203. These two networks I'm going to import on pod 1 to make sure I'm learning routes from outside. Okay, so 202.1.0.0/16, that will include the IP addresses for the OSPF configuration on the IPN on pod 1 side, and this would be 203.1.0.0/16. This will include all the IP addresses from pod 2 side of IPNs. Okay, and then we just go ahead and submit. Okay, I did something wrong. I extended AS2 and then 4. Let's go with the standard format. We can use the example one only. Invalid RN. What's the problem of RN? Alright, let's try to configure the pod fabric setup again. There was some issue with this lab. I have sorted it out. So Okay, let's give the extended community name or the basically the identifier in the format that is standard for this. We'll configure, we will keep everything same. This would be the IP tap address or IP address for the data plane traffic between the pods. For pod 1 this is 11.11.11.11. For pod 2 I'm configuring this to be 22.22, everything 22 here. This fabric external profile, again external profile, it's going to I'm giving a kind of a static route here for 201.1.0.0/16 and 203.1.0.0/16. So these are the network IP addresses which are configured on the IPN side. All right. There you go. Now after we have configured the multipod, we have actually created the multipod. Now we can now we have to create the routed outside network for the multipod. Now there are two ways to do this particular part. This is here basically we are configuring the L3 out for the multipod setup on this ACI. So one is you can do it from here, but I actually recommend doing it from the tenant infra tab, because there you can actually see step by step what exactly we are doing and where exactly we are configuring. So it's similar to the L3 out, any L3 out configuration that we do for any tenant. It's just that this time we are going to do it in infra tenant for the IPN devices, and those IPN devices and their network would be the L3 out for this particular infrastructure. So going under the networking, open, come on, what's wrong with you? What is wrong with you today? All right. Okay, so under external routed network, we are getting two options. One is for EVPN and the other one is for multiport. So obviously we are going to choose this option for now. So create a routed outside for the multipod, and we'll name it. Come on, give me a response. I'm sorry for this long wait, guys. Okay, let's name it multipod L3 out. Okay, and these two options will automatically be checked and you cannot even alter this. OSPF is for the neighborship between the IPN and the spine devices, and BGP is for the BGP and VPN4 to basically extend the two multipods. And we are going to give this a regular area. This router area ID, OSPF area ID is 1, which is the same which is configured in the IPN devices as well. If you remember, you can go back to the video and see over there. Okay, going next, now we have to configure the node profile name. This would actually help us configure what particular node from this ACI is going to connect to the L3 out. So we'll just name it that let's say for example we are only connecting spine 103, which is in this case in our diagram it's basically spine 102, 103, something 201, 202 is something like that, but in this lab we have two spines, spine 103 and spine 104. Okay, I'm going to keep the default timer BGP timers as default by not selecting them. The spine it would be it needs to be mentioned in this format, so I'm giving it pod. It's giving me two options, 103 and 102. I'll give it a router ID of 3.3.3.3, and we'll keep this as the loopback address as well. Then we can specify what interface of this particular spine is actually connecting to the IPN. So as per our diagram, which goes something like this, from the spine side this is 1/22 interface, 1/20 interface from the spine side. Okay, so similarly here I'll define 1/20 120, and I'll configure OSPF policy for sub interface. The configuration that I'll give is 120, because it's a point-to-point configuration that I've done. I want to advertise the subnet and I want to ignore the MTU, which is the same configuration that we did on the IPN side. So we have to match the configuration on both the sides. So we'll configure the routed sub interface here. The path would be like pod 1 here it is. Okay, node 103/ethernet 1/20. Okay, I'll give the IP address as 201 2.1.1.1/30 20, was it 201 or 202? 202. Okay, 202.1.1.1/30. I'll just update it. Now here what we can do, one more thing. It's kind of predicting the future here. After this complete multiport setup is done, so from here only we can configure the spine, the sub interface 1/20 for this particular spine in port 2 as well. Okay, so we can do either after this complete multiport configuration is done, or we can do it right now. If we know, let's say for example, on the port 2 the spine ID it's going to be as 203, right? So we can if we know, but if we don't, whatever it comes up after the discovery we can configure it later. So what we can do is basically we can mention it port 2 node 203 Ethernet 1/20, and the IP address that we can give there is /30. Okay, now it's not showing me updated. Why it's not showing me updated? Node 203 Ethernet, because the IP address format is wrong. Okay, so we have given it right here as well. We can do it after the multiport setup is completed. Okay, now here we have to give the BGP. This we don't have to give it right now. Here we are only going to configure the OSPF for us. So after this, just finish, and when you open that again, you can see all the configuration being done here. Okay, so there are a few important things which we still need to configure here. As you can see here, this is basically the logical configuration that we have done yet. Okay, we all know how to configure things logically as well as physically. So we have to configure the access policies for these spines and this particular interface as well, right? How can we do that? So first of all, we'll go to the fabric, the access policies, and we have to first create the external router domain, which is also called the layer 3 domain or the L3 domain. So this is multiport L3 domain. Okay, VLAN pool, you already know guys what VLAN pool I'm going to use here. I'm going to keep it static. The pool will be yep, you're right, 4. I'll configure the AEP for this particular L3 domain. So it's mpod AEP. Alright, I'll enable the infrastructure VLAN over this. I'll do the finish. I can map it from, okay, it's not showing over here right now. Let's submit it first. Go to global policies, AEPs. Do we see it? Yes, we see it. We can add the L3 domain over here. Okay, so this part is done. Now we'll configure the switch profile for spine. Create switch profile, spine profile. The name would be, as I'm configuring it on S103, so I'll just select S103, S103 again. The block that I'm going to use is 103, update it, do it next. Here I have to configure what interface that I'm going to configure, which is actually connecting to the IPN devices. Okay, so I'll do it a 1-20 because that is the interface that I'm working on. 1-20 interface ID 1/20 interface policy group. Here I'll configure the basic interface profile group mpod IPG. I'll do a CDP enable, CDP on. We'll attach the AEP here, and that should be done. Submit it, select this, finish it, work is done. Okay, that's all you need to configure. Now after configuring this L3 domain, we have to map this L3 domain to the logical configuration to make sure our tool parts, which is the logical part and the physical part, they connect to each other, they talk to each other. So external routed domain, mpod, submit it here, submit changes. So after all these things are done, the OSPF neighborship between the spines and the IPNs will come up, and they would actually be sharing the routes between them as per the policies which we have configured here. Okay, and okay, what else, are we missing anything? No, fabric part is done, access part is done. Okay, so spine L3 out domain is mentioned, the routes, it has the static route is mentioned. Yeah, no, so after this, as soon as this part is done and OSPF neighborship is done, what you can expect to see is under this fabric membership, right now I'm seeing all the interfaces or all the nodes for pod 1, but as soon as this complete configuration is done, you'll see the spine from port 2. It will be sending the DHCP IP request to the IPN pool, the IPN devices, and through those IPN devices we would actually be seeing these spines being discovered over here. Okay, and in addition to this port 1, you'll see port 2 here. You'll see that port 2 only, let's say for example, if this is the spine that you got discovered from port 2, so when it get discovered, it will show here port 2. You can name it and just give the node ID, and rest everything will be done. So here from this single API controller you can control the port 2 as well, and everything that you will be configuring over multiport. It's not like if you have one endpoint connecting in port 1 and you have another endpoint which is connecting in port 2, they can both lie in the same bridge domain as a part of same APG. That is the beauty of multiport, so basically we are extending single fabric over 2 locations, and after a complete multiport setup, you can judge, or you can refer an analogy saying that these IPN devices are the new spines of this complete pod, and this one pod is 1 leaf, the other pod is 2 leaf. So it's kind of a virtual ACI kind of a setup. So that's how they are extending the pods over different geographic locations, and then extending their infrastructure. Let's say for example, if they have data center where they cannot keep any more hardware to extend their data center, so this is a very good solution which big ISP clients and other big companies can opt to make a use of it.